let us study about collisions, right. So, given array elements, given some array elements, okay, 1, 2, 13, 22, 11, 5, 6, 1, 2, 3, 4, 5, then 17, 26. If I have elements like this and given a hash table size, you are given a hash table of size 7, okay, or let us take hash table size 10 also, right. You can take a hash table of size 10. Indexing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right. And the hash key, hash function given is key modulo 10 is the hash function. So, take the first element 1, 1 modulo 10, 1. So, I should place that here. Next 2, 2 modulo 10, I should place it here. 13, 13 modulo 10, I should place it here. 22, 22 modulo 10, 22 modulo 10 is 2, the remainder is 2. But if I see here, there is already an element. So, a collision is happening. That box is already occupied, but you are trying to place another element there which is not possible to store there, right. So, hash functions are used to map each key to a different address space, but practically it is not possible. We have seen just now, when you have 2 and 22, using this hash function, we are unable to store them in different place, right, to create such hash function, and this problem is called collision, right. Collision is a condition where two records are stored in same location. Already 2 is there, you are trying to fit 22 also here, right. So, collision is the condition where two records are stored in the same location. Okay. So, what are different collision resolution techniques? How to avoid this problem of collision, right. So, there are two ways of resolving that collision. One is direct chaining, other is open addressing. One is direct chaining, right. This is also called as open hashing. This is called open hashing, and open addressing, right, means closed hashing. There are two solutions, two ways of avoiding these collisions in hashing: direct chaining method and open addressing method. In this direct chaining, we have something called separate chaining, and in open addressing, we are having linear probing, quadratic probing, and double hashing. Using these four techniques, we can avoid the collision. We can avoid the collision while inserting the elements into the hash table. Okay. Collision occurs when you are trying to convert that key into an index using a hash function, right. So, you have to adapt some collision resolution technique so that collision does not happens, right. Let us study them one by one. What is this first method? Separate chaining method. Okay. So, in direct chaining method, we use an array of linked list, whereas open addressing we use array based implementation. Here it is linked list, here it is array. Directly an array is used. Okay. Let us see each of them, how to avoid collision. I hope it is clear. When you are having some certain keys with you, you want to store them into a hash table, those things. Sometimes the index generated for different keys is same. Okay. So, collision occurs. So, in those case collision occurs when there are keys for which we are getting the same index. When there are multiple keys for which we are getting the same index, such kind of incidents are called as collisions, which can be overcome by direct chaining or open addressing. Let us see one by one. So, first one, separate chaining method, that is our direct chaining method. Separate chaining method, what it does, see, when you have array elements with you, what is array elements given here? We are given 5, 10, 50, 11, 201, 33, 600 and 6. These are the elements given to us, and suppose you are having a hash table of size 7. Okay. So, this is my hash table of size 7. 0, 1, 2, 3, 4, 5 and 6. This is a hash table of size 7. Now, when you want to insert this 5, we are using our default method. Let that hash function be key modulo 10. Oh no, key modulo table size, that is 7. So 5 modulo 7, it is 5. So I will store that here. 5. Okay. Next comes 10. 10 modulo 7 means 3. So I will be storing here that as a linked list. I will store that 10. Next 50. 50 modulo 7, it is 1. So 50 comes here. Then 11. 11 modulo 7 is 4. So 11 comes here. Then 201. 201 modulo 7. If you calculate 720, 140, and then 210. So this is, what is the remainder here? 63, right? So 203, less than that. So that will be 49, 63, 56. So 296. So 5, 196. So that is 5. So if you see at the 5 box, at the 5 location, already there is an element 5. Here there is an element 5, but 201 is also coming in that location. So we maintain the elements as a linked list format like this. Okay, we maintain a linked list structure. You store the starting address of this linked list here in this hash table, and you are having different linked list structures to store these elements. 33 modulo 7. So it also give me 5. Why? 33 modulo 7 means 7 4s 28, remainder is 5. So that also will be linked here as a linked list 33 like this. Okay. So we are having separate chaining method maintains linked list. It maintains elements. Whenever there is a collision, it stores elements as a linked list format. But what is the drawback of this? Unnecessarily you are allocating memory for this temporary array, that is hash table, also for this linked list nodes, right? So this is the approach of separate chaining. What we try to do, collision resolution by chaining combines linked list representation with the hash table. We are combining, this is my hash table, we are combining that linked list with this hash table. When 2 or more records hash to same location, these records are constituted as a single linked list called as chain. You see, like this, you are forming a single linked list where the starting address of the list is stored in this hash table. This is one way you can avoid the collision, but the drawback here is you are unnecessarily creating memory for this extra linked list. Okay, this itself is extra. If you feel this is additional burden for us, using separate chaining method. So next method was open addressing methods. Next approach is open addressing methods. What is this open addressing? In open addressing, all keys are stored in the hash table itself. Here we were storing in linked list, but here we will be storing in the hash table itself. This approach is known as closed hashing. Why? Storing the element in the hash table itself. That's why it is called closed hashing. Okay, this procedure is based on probing. Okay, this is based on probing. Let's try to understand what is probing. So first one is linear probing. The first one is linear probing. What is this linear probing? Right? I will take an example and explain you. So if I have an array elements, some set of keys. Okay, I have some set of keys 7, 12, 15, 13, 4, 6, 17, 19, 32. Suppose these are my key elements. I want to store them. In the hash table. And the hash function which I am using 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's take one more element. Maybe I can take 15. Okay, there are 10 elements with me. So my hash table size is 10. Assume my hash table size is 10. Okay, I want to store them in a hash table of size 10. 0, 1, 2, 3, 4, 5, 6, 8. 0, 1, 2, 3, 4, 6, 7, 8, 9. This is my hash table size, and my hash function is key modulo table size, that is 10. So where will 7 go? 7 will come here. Then what about 12? 12 will come here directly, 12 modulo 10. 15 will come here. 13 will come here. Next 4 will come here. Next came 6 will come here. Next came 17. See, what is the linear probing approach? Linear probing says that, okay, we are trying to avoid collision, right? We are trying to avoid collision. I have an hash function, I have the key elements with me. I am filling all those elements happily. Key mod 10, I am applying them. But when I want to insert 17, when I apply hash function, that key modulo 10, that is 17 modulo 10 is giving me 7. 7 is already occupied with a number. So linear probing says that when that element is filled already with a existing number, then go to its next location. Go to its next location. If it is free, fill it there. So after 7, the next box is 8. The next box is 8. It is free. So put 17 here. Put 17 here. Next comes 19. 19 modulo 10, that is 9. So 19 comes here. Next 32. See, the next element which I am trying to insert is 32. You apply the key. What is 32 modulo 10? It is 2. 32 modulo 10 is 2. So go to the box number 2. Is the box number 2 empty? No. There is some element already in this. There is some element already into this 2. At location 2 there is already an element. So what should I do? What does linear probing says? Linear probing says go to the next location, fill it there if it is empty. Go to the next location, fill it there if it is empty. Right. So I will go to the next location, it is also filled, next location fill, next location fill. I can come out of this. I cannot fill this 32 because I have accessed all the elements, everything is full. Everything is full. Then what can you do? The other way of doing is this, you can, instead of having 10, you can have modulo, right, n plus 1, key plus 1 you do. Okay, that key plus 1 modulo 10 you do. Another strategy, instead of key modulo 10, now you do key plus 1. Now let us see what happens here. Right, I am having boxes. Okay, 7 plus 1, 8. 8 modulo 10, 8, location 8. 1, 0, 1, 2, 3, 4, 5, 6, 7. There should be 2 boxes here, like this. Okay, the first element is 7. So 7 modulo 7 plus 1 modulo 10, that is 8. So 7 comes here. 12 plus 1, 13 modulo 10. So it comes at 3. 15 will come at this location. Again 13 plus 1, 14. 14 modulo 10, 4. So 13 comes here. Then 4. 4 plus 1, 5. 5 modulo 10, 5. So 4 comes here. 6 plus 1, 7. 7 modulo 10, happily. 17. 17 plus 1, 18. 18 modulo 10, 8. Okay. 17 plus 1, 18. 18 modulo 10 is 8. You see, 8 box is filled. What does linear probing says? Go to next location. So put 17 here. Then 19. 19 plus 1, that is 20. 20 modulo 10, 0. So 19 comes here. Then came 32 plus 1, that is 33. Modulo 10, it is 3. Third box is fill. Go to next location, not free, not free, not free, not free, not free. From here again come back to top. It will come back to 0. Okay, 19 not free. Then you will fill 32 here. Okay, next 15 plus 1, 16. 16 modulo 10, it is 6. Right? So 6 box is already filled. Then look for other place, next, like this. You will be putting 15 here. Right? This is the approach of linear probing. Simple. Linear probing will apply the hash function. It will generate the index. At that index, if it is already filled, go to next empty space. Go to the next empty space. Like this, you keep repeating this. This is our linear probing approach. Let us understand this. In linear probing, we search the hash table sequentially, starting from the original hash location. Whatever hash function is giving, that you use it. Okay, if it is already filled, go to next location. If a location is already occupied, we can check the next location. We wrap around from the last table location to the first table location if necessary. That is, from the 9th location again you can come to 0th location. The function for rehashing is n plus 1 modulo table size. Okay, n plus 1 modulo table size, right. So, one of the problems with linear probing is that table items tend to cluster together in hash table. There is a chance that all elements can come at same location. Okay, there is a chance of clustering, meaning when I have hash table of size 10 like this, there is a chance all elements can be something like this here only. In between this range, this is empty, this is empty. All elements form a cluster in the between only. Okay, there is a chance of this, right. That is one drawback of linear probing, right. So, clustering causes long probe searches and therefore decreases overall efficiency. So, linear probing, how to, I will repeat once again the linear probing example. If I have some keys, okay, 7, 2, 5, 3, 9, I have some keys with me like this, right, and my hash table size is 10. What is my default hash function? That is key modulo table size. So, in my hash table, I will be filling those values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, the original hash function is key module table size, that is 10. Okay. So, fill 7 modulo 10, 7 comes here, 12 comes here, 13 comes here, 15 is okay, 14 comes here. Again see, after till 14 okay, when 7 came, 7 modulo 10, it gave me 7, but the 7th location is already filled. Then apply the rehashing function, that is n plus 1 modulo 10, that is 7 plus 1, 8 modulo 10 means 8, that is what I said. Fill it at the next location, fill that 7, 7 already came, now let us take 17, 17 modulo 10 is 7, right. 17 plus 1, 18, 18 modulo 10, 8, fill that 17 here. How did you find the next location? We fill it using key plus 1, see n plus 1 modulo table size. Next came 2. So, 2, first apply this, 2 mod 10 is giving me 2. Is this 2 location empty? No. Then you do 2 plus 1 mod 10, that is 3 mod 10, it is also filled. Then again increase 1, it is filled, then come here and store 2, because we found out an empty element here like this. Then you fill 5, 5 will go here, then 3 will come here and 9 will come here. Like this we can fill the elements. This is the approach of linear probing. Okay. Collision resolution techniques, in that we have seen 2 techniques. One is separate chaining method, the second one is linear probing method, right. Let us see how do we overcome the drawbacks of linear probing using the next method, that is quadratic probing. Okay. What is this quadratic probing, right? Your basic logic will be same, key modulo your table size to fill the element. Okay. Once a collision is occurring, in quadratic probing method, what we try to do, to find out the new key. In linear probing, it is key plus 1 modulo table size, right, in linear probing, whereas in quadratic probing it is n plus k square modulo table size, n plus k square modulo table size, where k is ranging from 1, 2, 3 and 4 and so on. Meaning, if first time some collision is happening, you will be adding key plus 1 square, but that second box is also already second box also contains some element, then you will move for 1 I plus 2 square, then I plus 3 square and so on. Let us understand this with an example, how this quadratic probing works. Okay. See, so I have a table size of 11 with index 0 to 10, right, and hash function is key modulo 11, basic hash function is key modulo 11. Okay. So, let me take that empty one, I am taking a hash table with me of size 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. Now, I want to insert 31 for example. So, 31 modulo 11. What is the value? 11, 2 is 22, the remainder is 9. So, 31 comes here. Then, the next element is 19 which I want to insert. Okay. 19 modulo 11 is 8. So, 19 will come here. Next, 2 modulo 11. So, 2 modulo 11 will give me 2. Okay, happily I will put it here. Then 13 modulo 11. What is 13 modulo 11 value? It is 2. But if you see that box number 2 is already filled, it already has some value. Then you have to find out the rehash value. In quadratic probing, what is my rehash value? Rehash value is key, okay, plus how many collisions happened now? This is first occurrence, right? Only one collision happened, right? When I inserted 2, 2 is already here. When I came with 13, I could see there is one element. So, for 13, this is the first collision. So, I will be using key plus 1 square modulo 11, right. So, key is, that is 13 modulo 11 is 2, 2 plus 1 square is 3, 2 plus 1 square is 3. So, at location 3, we will be including our that value, that is 13 here. Next, take another value. Next entry is 25. Okay. So, what is 25 modulo 11? 25 modulo 11 is 3, because 11 2 is 22, 3. So, if I go and see, 3 is already filled. 3 is already filled, and this is the, for 25, this is the first encounter. This is the first collision. So, 3 plus 1 square modulo 11, that is 4 modulo 11. So, happily I can put 25 here. Okay. Next, the next element which I want to insert is 24. Okay. So, 24 modulo 11 will give me 2, 11 into 2, 22, 2. But when I go and see in location 2, it is filled, it is filled. Now, you do that linear hash quadratic probing. What is that? That 2 plus 1 square modulo 11, that is 3 modulo 11 is 3. When I go and see, first time I got collision here, I got a new value, that is 3. When I go and see at 3, there is already an element. So, again a second time collision happened, second time a collision happened. So, you will take 2 plus 2 square this time modulo 11. What is 2 plus 2 square? 6. 6 modulo 11 is 6. So, the number 6 is free, you will be placing your 24. Okay. So, whenever the collision is happening, you are increasing that complexity. Let us see one more example, you will understand it better. Let us insert few more elements into this. Next element is 21. 21 mod 11 is 10, happily 21 will come here. Now, see for 9 mod 11. For 9 mod 11, what is the value? 9. I could see 9 is already filled. So, one time collision happened. You find out the new value by 9 plus 1 square modulo 11. So, 9 plus 1 square is 10, 10 modulo 11 is 10. But I could see 10 is also filled again. 10 is also filled again. Now, what you have to do? You have to do second time. You have to do it second time. So, 9 plus 2 square modulo 11. That is 9 plus 2 square means 9 plus 4, 13. 13 modulo 11 is 2. This is also filled again. This also filled again. Again update 9 plus 3 square this time, because third time also collision happened. So, 9 plus 3, 9, 9, 18. 18 mod 11, 7. Yes, 7 is free. We got a new location for 9. This is the approach of quadratic probing, which reduces the number of collisions and tries to insert all the elements into the hash table without collisions. Okay, without any problem, it is trying to create. So, it is little better than linear probing. We do not say this is the best solution, but only thing it is better than linear probing. Okay, but still there is a chance of clustering here. Even though clustering is avoided by quadratic probing, how it is avoided? Clustering is avoided by you are jumping in 1 squares, 1 then 4 then 9, like this you are increasing 1 then 4 then 9 and then 4 square 16, like this you are increasing the value. So, the values are distributed across the hash table. Clustering is not happening. Still there are chance of clustering, even though still there are chance of clustering, okay, even in quadratic probing, right. I hope you understood this approach. In quadratic probing, first we will use the base key, that is key modulo 11, that is table size. If some collision is happening, then we will be applying rehash function, that is n plus k square, like this, 1 square, 2 square, 3 square and 4 square and so on, so that we get a better or a location without any collision on the hash table, right. This is our quadratic probing approach, but still the problem of clustering little exists even in this method. So, the third method in this open addressing is double hashing, closed hashing or open addressing, right. Open addressing, we are having three techniques: linear probing, quadratic probing and double hashing, right. So, this one is third one and the last one. Let us see what is double hashing. Now, in first two cases, in linear probing and in quadratic probing, you are using one hash function h1, right. You are using one hash function, that I may say key modulo 11 or 10 is your one hash function, right. If there is a collision, you are modifying that hash function, that is you are doing key plus some I square, 1 square, 2 square or key plus 1 in linear probing, right. Here we will be using two hash functions, here we will be using two hash functions, okay. Double hashing, meaning your the finding out the new location for the collided one, okay. If collision is happening for a number, to find out its new location, we will be using another hash function, okay. Let us see this example. It is little complicated to understand, please understand this with an example, okay. So, assume I have table size of 11, so I will just create this, this you can ignore, I will just create a hash table of size 11, right, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and a 10, okay, right. So, I want to insert the key 58, I want to insert the key 58, and the table size is 11, 58 modulo 11, basic standard I have to apply. So, 58 mod 11 is 3, so I will put 58 here in the location 3. Then 14 mod 11, next one is 14 mod 11. What about 14 mod 11 value? It is also 3, it is also 3. So, in linear probing what you are doing? You are putting it in the next location. In quadratic probing you are doing same thing. In quadratic probing also 3 plus 1 square means it will also go to this next location. Whereas in double hashing, that what is that key? See, 14 modulo 11 is giving me 3. In linear probing I was doing 3 plus 1. In quadratic probing like this. In quadratic probing I was doing 3 plus 1 square modulo 11. Here what this value, that 1 or 1 square is decided using another hash function. It is decided using another hash function. What is the hash function here? See what we got here, right, 3. We got the value as 3, right. So, the second hash function is key mod 7. The second hash function is, this is not, it is key mod 7. So, 3 mod 7 value, right. Let us again see here, key 7 minus key mod 7, right. So, key value which I am inserting is 14 mod 7, right. See, second hash function h2, 7 minus key is 14 mod 7, that is 0. So, second value became 7, right. That is, instead of adding this 1 square, I will be adding 7 here now, okay. 3 plus 7, 10 modulo 11, 10, there I will be placing the 14, okay. We will understand this. Let us take more numbers and see how I am doing that, right. So, next the third number is 91. So, 91 mod 11 is giving me 3, okay. When it is giving me 3, you go to second hash function, use this second hash function. I have to add something to this, I have to add something here, x modulo 11 I have to do. In linear probing this x is 1, In quadratic probing, this x is 1 square, 2 square, 3 square, but in double hashing, I have to find out this x using another hash function h2. What is that? It is 7 minus 91 modulo 7. That is the key which I have defined. So, what is 91 mod 7? 91 mod 7, if you calculate 7, it is 0. 91 mod 7 is 0, remainder is 0. 7 minus 0 is 7. So, I have to add here 7. 3 plus 7 modulo 11. What happened? 3 plus 7 modulo 11, we found that this value is 10. You see, 10 is also already occupied. 10 is also already occupied. Now, you have to find out the next one. How do you find out the next one? Again, key. So, here you will multiply it with 2, right? 2 into 7. So, the probe value, that which value should I add? Key plus 1 is linear probing. Key plus 1 square, 2 square, 3 square is quadratic probing, right? That key plus this x, the new element which I am adding, is found out by using another hash function, that is your double hashing. Why? We are using two hash functions. We are using two hash functions. So, in this case, when 3 plus 7 modulo 11 gave me 10, which is already occupied, then 3 plus 2 into that 7, that is 14. 14 plus 3, 17. 17 modulo 11, 6. So, this 91 goes into 6. 91 goes into 6. Next, take another example, right? The next element is 25. 25 mod 11 is giving me 3. I could see 3 is already filled. Then what I have to do? I have to find out the new key value. How to find out that? 7 minus the key is 25, right? So, 25 mod 7. Okay. So, 7 mod, what is this value? 25 mod 7. 25 mod 7 will give me 7 3 is 21, remainder is 4. 7 minus 4 is 3. So, 3 plus 3 mod 11 you do. 3 plus 3 mod 11, 6 mod 11 is 6. 6 is also again occupied. Then multiply this 3 into 2. Okay, multiply this 3 into 2. It is something like 3 plus 2 into 3 now. Again mod 11. So, 3 plus 6, 9. 9 mod 11 is 9. 9 is free. I will be putting 25 here. Okay. So, in double hashing, you will be first finding out the initial location using this hash function h1. If there is a collision, you have to find out the new. In linear probing, we are adding key plus 1 fixed. In quadratic probing, we are adding key plus some I square, where I will be 1, then 2, then 3 and so on. Whereas in double hashing, your k plus this new value will be found out using another hash function h2. This will help us, this h2 will help us in finding out the new location. Okay. It is believed practically, after doing lot of experiments, it is believed and assumed and found out that the double hashing is better compared to linear and quadratic probing. It fills the value nicely without collision, okay, and it is much effective compared to both of them, right. So, this is an example of that. So, see here, the interval probes is computed by another hash function. Interval probe means that h plus 1, 1 is the probe in linear, okay, k square is the probe in quadratic, whereas in double hashing, that probe is identified by another hash function. Double hashing reduces clustering in a better way, not 100%, but better way compared to other two. The increments for the probing sequence are computed by using a second hash function. We use that. How much to add here is decided using second hash function. Okay. So, the first, see, the first probe location h1 key, I will use this. If it is already occupied, h1 key plus h2 key, okay, h1 key plus what h2 gave to me, I will add it. If that is also occupied, then h1 key plus 2 into h2 key. If this is also occupied, then h1 key plus 3 into h2 key and so on. That is what we have done in this example here, right. First we are adding h1 plus h2, whatever h1 gave, and whatever H2 is giving me, that is occupied. Then I go for H1 plus 2 into H2. Now I got a unique one. If this is also occupied, then you will be going for 3 plus 3 into 7 mod 11. Okay, 24 mod 11, like this you will be going here, right. So, this is the concept of double hashing. So, to avoid collisions, we are having 4 different approaches, right. One is separate chaining, that is using linked list, but unnecessarily we are allocating more memory. That is why it is called open hashing. Why it is called open hashing? Because the values are kept outside the hash table, whereas in open addressing this is called as closed hashing, because we are storing the values in the hash table itself. In that we are having linear probing, linear search, quadratic, non-linear search, double hashing, you are using 2 hash functions, right. So, this is about different collision resolution techniques what we have in hashing.